Nice to see you again, Liz. How are you doing?
I'm doing great. Thanks for the introduction, Yulia. And hi, Andy. Good to see you.
Yeah. It was a really great keynote, and I listed down a bunch of questions that were in the chat and the Q&A that I think we can go over here. And we have permission to get a little bit more geeky and technical in this session if we want. So nothing off limits. One of the comments was that this looks really interesting, but everything's way too much code. I'd rather have like a pre-built module that I can just load.
Huh. Well, I guess that's what the tools like Cilium and Falco and Inspector Gadget and all of these things give you is, somebody has already done the work to write a lot of eBPF code and a lot of user space code to interact with that eBPF code to make things, usable tools that hopefully make your life easier. Yeah.
Yeah. But if you want to know a little bit more about how it works, I understand there's a book out about that.
Yes, there is. Yes. So Learning eBPF, which just recently got published by O'Reilly. I still haven't got the physical copy yet. I think they're being, shipped on their way from the printer as we speak. So I'm very excited to, it's definitely a thing when you get a copy of your book physically. But yeah, it's out now. You can download a copy from the Isovalent website under isovalent.com/learning-eBPF. You can also, it's available from all good bookshops. Order it from like bookstore.org or bookshop.org, and you can support your local bookshop rather than the giant multinationals.
That's a good tip. Good tip. So we were preparing for this, and I told you that I've ordered my paper copy because I want to bring it to Amsterdam, and hopefully I can get it signed by the author.
Absolutely, yeah.
And you said that, hey, would you like an electronic copy in advance, while you're waiting, so we can talk about it. So I got it, and Liz, I have to make a complaint.
Okay, go on.
I think you're missing a content warning. There needs to be something on like the cover that says, if you're a geek and you love learning how things work and you have a significant other with a very long list of things you need to do during the weekend, do not open this on Friday afternoon.
Am I going to be held responsible for divorces around the world?
No. But I do love, I really like, I've been using Cilium since 2018 or something, quite a while. And I really love how eBPF works and whatnot. But it's like, it's part of a tool that I install and I use. And that's enough most of the time. But I like kind of digging into it. So I got the book and I'm scrolling through and thought, I'll just put it on my tablet and read through it and it's fine. And then I got to a code example. And, I have an iPad mini, so it's kind of small and sweeping back and forth between the pages. It was not great for looking at code. So I came into my desktop and I opened up GitHub and looked at the accompanying repository, looked at the code, did a checkout. It's in VS Code, my editor with my style highlighting everything. This makes so much sense. Okay, cool. Then I read a little bit more. I think I could. And then do a little bit of typing and like, oh, hey, this is cool. This is great. And then, a few hours later, are you still in there doing that? Sorry.
Oh, that's really great that you've enjoyed working through the examples. That's really great to hear.
And actually, I wanted to show a little bit just because I think it's cool of what I did. So let me move this window open and I can share. I want to share my entire screen. Okay. So I went through and a little bit of copy paste, I'll admit. But I made my little Python app here, which basically is just looking for all the open events for opening any files. And if there's something, if anybody opens etc sudoers, then I'm going to assume they're trying to do a privilege escalation. So it's going to print stuff out to the screen and send something to Slack. And let's just see if this works. Okay, it's watching something. Now I'll go here and I'm just gonna, hey, I'm editing my file. We see something printing out over here. And, just a second. My Slack is telling me that somebody's trying to compromise my laptop.
Wonderful.
Success, it worked. And of course, I'm not in the position right now that I'm going to be writing eBPF programs. That's just not what I'm working on. But I love so much that you've gone into so much detail of listing how it works, because now this totally makes sense to me. And when I see a program like eBPF, like Cilium or Tetragon or something, Falco, which is using this, it makes sense to me how it's working under the hood, which just, for me, unlocks a lot of value and trust that, hey, this is really a cool thing.
That is great. Yeah. I mean, that's kind of how I learn things myself as well. You know, I'm not really I find things hard to absorb when it's just sort of boxes and lines and diagrams and things. You know, I need to feel the code. And then once you see some examples, you can extrapolate from there. You know, okay, I'm not going to necessarily write, you know, a fully fledged Cilium from scratch, or I'm not going to write a fully fledged Tetragon from scratch, but I have a sense of how, you know, if I really needed to, how I would go about it and how it's working. Yeah.
And for everybody in the audience, we do have this Q&A tab, so feel free to put your questions in there. And I'm watching this. There's none yet. So since you guys haven't asked any questions, I'm going to ask mine. There was a question during the keynote about how can we trust that this isn't going to crash the kernel? And I know that we have this process called a verifier. I think it's called a verifier, but anyway, it verifies. Yeah. And just wondering, can you walk through a little bit how that works and how it actually verifies the code of the eBPF module?
Yeah, and I also happened to notice somebody also asked the question, did the example that I showed go through the verifier? And the answer is yes, it did. Every time you load a program, a BPF program into the kernel, it's going through that verification process. So BPF programs are bytecode instructions that are going to be executed in like a software virtual machine inside the kernel. So it's got its own, very similar to machine code, instruction set. So you've got this program, you load it in a form of a series of instructions into the kernel. And the first thing that happens is the verifier's going to look at that, sort of step through those instructions as if it were executing them, but rather than actually executing them, kind of keeping track of the state. So it's going to walk through every possible path. If there's a branch instruction of some sort, it'll kind of go, okay, I'm going to explore one path of that branch, but I'm also going to keep hold of the state so I can come back and check the other branch as well. And it's counting how many, as it goes through all these different branches, if it reaches 1 million instructions, it's going to say, actually, this is too, maybe this is never going to complete. I'm going to not pass this because I'm not sure it's going to complete. Every time there's access to memory, it's going to check that that kind of memory access is a valid thing to be doing at that time. So, for example, if you're in the context of looking at a network packet, you're allowed to look at the network packet, but you're not allowed to look at, user process memory or something like that.
Right.
And it's also going to check that every single time you dereference a pointer, basically, that it's explicitly checked that that it's not null. So, that's the kind of classic way to crash a machine, is to dereference a null pointer. So it checks for every single memory access. And there's been a lot of work done over the years to make that verification process more efficient and to kind of optimize it in terms of like if I've seen this state before, I don't need to check the same state again. I know that I've seen this before. And that's essentially how the verifier works. There's a chapter in the book actually that goes into a bit more detail on a set of the tests that it's going through.
Yeah. Okay. Let's see. We got our first question from the audience. How can you estimate the impact on performance of BPF program properly? Like, yes, there's testing, but with kernel stuff, that could be a lot of tests, which basically means not all would probably be tested, I guess you meant to add. Do you have any instances when eBPF would make a major impact on performance unexpectedly or something like that?
So in the context of just having talked about the verifier, you only have to go through that verification process once when you load the program into the kernel. And then every time an event triggers, it's already been verified. It actually goes through like a compilation process that it's been turned into native machine code. So once you're starting to execute the program in response to an event, you don't have to go through this whole verification process every time, which is a relief. So it's very hard to say, quantitatively, like how costly is eBPF? It's like, well, it depends. Depends what your program is going to do. It depends how complex it is. Depends how many times it's being triggered. So, I think if I wrote a pathological example where I don't know, attach lots of eBPF events all over the place, that could have an impact on performance. One of the good things about eBPF that I didn't talk about in the keynote is the fact that you don't have to go through context switches. So normally, if you're transitioning between kernel and user space or vice versa, it's actually quite a time-consuming process, relatively speaking. So you want to avoid those kernel transitions if you can. eBPF doesn't require any kernel transitions. You can you're in the kernel context already. You can run the program in that context. There's no cost of transition. So that makes it very efficient. I think, do we have any quantified examples of how costly it is to instrument things with eBPF? It's going to depend. I did recently see, and I'm struggling to remember exactly what the example was, but there was an example where someone was instrumenting something quite thoroughly, and it was like a 2 to 4%, I think, CPU use cost. So you might see some impact, but it's not going to dramatically affect things relative to. Certainly, it's going to be more efficient than the equivalent observability you might get from a user space process, simply because you don't have to do all those transitions all the time.
Right. And I guess it's also worth mentioning that the way the kernel works, these processes are firing kind of notifications and events all the time, because that's how different parts of the kernel understand that now they need to do something. So we're not really injecting more work for the kernel to do. We're just saying that, hey, after this has been verified and loaded, listen for those things to happen.
Yeah, you're attaching to, and actually even the way that programs get attached to events is another thing that's been optimized and improved over the years. I mean, it's certainly true. If I write an eBPF program that, I don't know, just does one if test, that's going to be less processing than if I make it go through some giant loop processing lots of things before it completes. So you can write eBPF programs that will use some CPU, not completely negligibly, but it very much depends what it is. It's at the end of the day, it's just code. So just like you can write an application really efficiently, or you can write an application to be really ponderous and annoyingly slow, you could do the same thing in eBPF.
Yeah. We have another question here. Can you namespace scope an eBPF program so it only works in certain namespaces, for example, where you're not expecting certain activities?
This is a really great question. So there's a couple of different interpretations of the word namespace, but I think for this question, they both kind of the answer is going to be the same. So there's Kubernetes namespaces that we're often familiar with for dividing up clusters resources amongst maybe different projects or different teams. So one team might have access to one namespace, another team might have access to another namespace, and they want to be able to do things independently and manage tooling independently and so on. The other kind of namespace is Linux namespaces, which is one of the constructs that containers are made from. So I talked in my talk about network namespaces and how you isolate one pod from another using these Linux namespaces. Both of these things are essentially kind of transparent to the kernel. If I hook an event in the kernel, it's going to fire regardless of the name. So I could make I could go down a rabbit hole about networking namespaces here, but let's set that aside for the moment. Generally speaking, let's say I hook into a system call event. Doesn't matter what Kubernetes namespace, it doesn't matter what container, and therefore Linux namespace triggered that syscall. It's still going to trigger that event. What you do with that event could be filtered to a particular namespace. And you'll see this a lot. For example, Cilium or in the Inspector Gadget example that I showed, you can, I'm pretty sure you can certainly view results from a particular namespace. Question where your tool is doing that filtering. So you could filter it in the kernel, and this is one of the advantages of Tetragon, because it's going to do things like, okay, my policy says maybe I'm only interested in looking at files in the etc. directory. I could pass all of the file events to user space and then filter it there. Or if I can filter it in the kernel, then I have a lot fewer events that I'm going to send to user space, and it's going to be more efficient. So I think Tetragon is probably one of the few kind of observability tools that's doing that filtering in kernel. It can get pretty complicated, but it's going to really impact the performance of that tool.
Right. With my silly example I just showed, I'm just like listening to all the file access events, and then in the eBPF part, and then in my Python part, if the file is this, then trigger the notification. So I think that that's kind of exactly what you're saying, that filtering needs to be done. The kernel is going to fire for everything, but where we filter can give us different levels of benefit.
Yeah, exactly. So the passing the information between the stream of events that are being triggered, you're probably using a map to pass that information between kernel and user space. And it's a very efficient mechanism, but the fewer events you put into that stream, the less processing you need to do at the user space side, and therefore the more efficient it can be. Yeah. So it's an example of, I guess, developments in eBPF tooling that we're just starting to see now, really.
Yep. All right. In the keynote, there was also a question about how can we load this if we're using, for example, a managed EKS or other managed Kubernetes service, which is hosted by the cloud provider. How can we load stuff into the kernel?
Yeah, really great question. If you don't have access to the machine, you're going to struggle to load eBPF programs. If you've got privileged access, so if you're allowed to run privileged containers, or if you're allowed to run with the capabilities that you need for BPF, there's cat BPF, and depending on the type of eBPF program, you might need cat net admin or cat sysadmin. But if you've got those capabilities, you can run a container with those privileges, and then you could use that to load an eBPF program. But it's certainly true that some managed environments will not allow you to do that because they don't want you to be able to mess with the underlying node. Right. So, yeah. And this is one of the reasons why, although I think eBPF is a better model for most situations, I don't think the sidecar model is going to go away entirely, partly because of this, the situations where you can't necessarily load eBPF. The other alternative is, of course, that managed cloud provider might support eBPF-based tools and might allow you to install eBPF tools. Maybe there's a marketplace offering where you can install those kind of tools.
Yeah. I've been using Cilium, which is, of course, is eBPF, and I think all the major cloud providers without any problem at all. You do have to make sure that for these containers you're running, you have privileged access. And do you do that per namespace or just for the container or whatever, just how you want to use your Kubernetes? But you do need the privileged access, but I haven't had any problems with it. But I can totally envision the point that there would be a provider that says, no, you can't do that. We don't give you that access. So
yeah, I guess an example might be, if you're in a serverless environment, they're probably not going to let you.
Sure. Yeah. And just again, for the people in the audience, please throw in your questions. So I'm going to ask anything that you ask. So, and here we just got one. I saw previously your code was wrapped around Python. Is that right? Or is it better to use pure C? And do you notice any speed difference? My code, which I showed, is wrapped in Python. And in your book, you mentioned you can use Python and do it this way. And then you have other examples. So, but what's your answer for this?
Yeah. So when we're writing eBPF tools, we have to write the eBPF program itself. And we probably also write some user space code. Like you did in your example, you've got the program that's detecting the event, and then you've got some user space code to kind of filter and then send Slack messages and write things to screen. So that's pretty typical. The eBPF code I mentioned has to, when it's loaded into the kernel, it's in the form of bytecode instructions. And we usually write that, well, we could write eBPF programs in bytecode directly, but I'm a human being and I have other things that I want to do with my time rather than write hex code. So
I was going to ask, what do you mean by we? I certainly can't.
It is theoretically possible. So I would choose to write in C. You can also write in Rust. And the reason why you can use those two languages is because the compilers support compiling to that bytecode instruction set as a target. You can't compile from, let's say, Go or Java. And the reasons for that are, things like garbage collection, which are just incompatible with eBPF and the way that eBPF is executed in the machine. So you've got choices for that eBPF program, C or Rust, or writing it in bytecode. For the user space part, you've got a lot more choice, and you probably want to use a language that has some kind of library support so that you don't have to write directly to BPF system calls. There's quite a few different libraries available. When you've seen Python examples, I'm imagining you use BCC for that example. Really easy to get off the ground. For reasons I wouldn't necessarily say it's the best choice for a production tool that you're going to ship to lots and lots of different environments. In those cases, there are things like libbpf, there's the Cilium eBPF library in Go. For Rust developers, there's something called Aya. There's probably another half a dozen that I'm not springing to mind right now, but you have a lot of choices. So then you can, make your choice about what languages you're familiar with. And, is Python faster than pure C? Or is C faster than Python? Well, yeah, compiled, and it probably is going to be faster, but it depends on your application, whether you care about the tiny change, the convenience of writing in a language that you're familiar with can be a huge advantage. Yeah.
Yeah, the last line of his question says, did you notice any speed differences? And I think that's what you're just alluding to, that, yeah, sure, there's some differences between languages, but depending on what you're doing with it and whatnot, it may or may not be a wise choice anyway.
Yeah, I mean, in general, for performance reasons, I would always opt for a compiled language. And, certainly, again, there's lots of, depending on how critical performance is, you might make different choices about languages. Yeah.
Right. If I'm writing kind of like just some kind of update health check kind of thing, which is going to run once a day, Python's perfect. It's fine. Just get it out, especially if you know Python. But if you're talking about
the language you can write that code in, if you can write it, that's a lot better than trying to write in something that it's going to take you a year to learn how to do it.
Exactly. But if you're going to try to examine every single packet and the contents of the packet to make sure it doesn't have some malicious value, Python might not be the right choice for that use case.
Agreed. Yeah.
All right. There's a question here. If you would like to use AI in eBPF, would you like to train the model in eBPF or out of the kernel? I think that if I'll give my answer and then give you a little bit of time to think. I did when I was during the weekend just ask chat AI that, hey, what's a BPF program to da-da-da-da-da? And I looked at it and it was interesting. And my whole way of looking at AI and all these chat GPTs and whatnot is it's really, really good at giving you a quick answer and doing some research for you. It gives you a very good high school student level of quality with like a late 20s white guy in tech and a VC-backed startup level of confidence. So, if you know exactly what you're looking at and you just want some help to get you most of the way there, and then you fine tune and you can see where the problems might be, it's fantastic. But if you're just like, hey, teach me this, it gets you pointed in the right direction, but I wouldn't really trust it out of the box. And I think for eBPF, it might be kind of the same thing, that it's good for, it can go out and look at different models and get different examples and say, here's an idea. But that's never going to replace the kind of a human looking at it and understanding how things work.
Yeah, I can certainly imagine some examples where AI could be really interesting and useful in conjunction with eBPF. So maybe spotting malicious activity. You can write rules. I can handcraft some rules to say, this behavior followed by that behavior maybe is suspicious. But maybe we can use AI to kind of develop policies and learn, what's the difference between legit behavior and malicious behavior. Mm-hmm. So maybe we use that to develop the policies. So the question's asking, would I train the model in eBPF or outside? My understanding of AI, and I am, I did a tiny little bit of, like a course on neural networks and stuff a few years back. Just, so I've got a probably dangerous amount of knowledge. But I think to train a model, you need access to a lot of data. And you're probably going to train that model. You might do the training sort of distributed because you're going to have lots and lots and lots and lots and lots of kind of looking at the same or slight variations on the same thing to train that model. I don't think you would want to do that in the kernel. I'm not sure that would be much benefit in doing that. You probably want to have it distributed across multiple machines. But I could see using, in my example, I'm saying, security policies, potentially having those enforced within the kernel could be really powerful. Yeah. All right.
There was also a question, we were talking about, can you run eBPF in the managed environments in cloud providers and whatnot? There was another question that I noticed in the chat that if the cloud providers put something in with eBPF for their monitoring and I put my own thing in, are we going to end up with conflicts, and how would that affect?
Yes. So it is possible to have conflicts. Depending on the type of program, you can end up in a situation where you can't have multiple eBPF programs trying to attach to the same event. So that can be an issue. You could also have eBPF programs that are, maybe attached to different places in the networking stack or different places in the, in the runtime aspects of the kernel that are maybe, for whatever reason, in conflict. So yes, it is possible that you could see conflicts. There is work that's been going on in the eBPF community to sort of help with this management of what if I want to have multiple programs essentially looking at the same event, and how can I order them correctly? So that's a fairly cutting edge thing in eBPF itself. As you were starting the question, the way I thought it was going to go is, does this mean my cloud provider can observe everything that's going on in my applications? And the answer would, of course, be yes, but then they can anyway because you're using their machine. But you could use eBPF and eBPF tools to look to see what eBPF programs are running on those nodes.
Mm-hmm. Yeah, there's a bit of discussion here and there, and some interesting services coming around confidential computing in the cloud. Mm-hmm. Mm-hmm. And I think that's really interesting and probably very, very well intentioned. But if you don't trust the cloud provider you're running on, why are you running it there?
Yes, very true.
I think that's what. All right. And I don't see any other questions, so I'll jump to my next one. You've mentioned a couple times Tetragon. What's Tetragon and why is it interesting?
So Tetragon it's a sub-project from the Cilium team, although that team is kind of like kind of growing and going off in like a different direction with Tetragon. So it's using a lot of the experience that the Cilium team have learned from working on Cilium itself, a lot of this eBPF expertise and a lot of kernel knowledge. So one of the interesting things about kind of the history of eBPF and Cilium is that particularly on the networking side, a lot of the eBPF capabilities were actually driven by Cilium engineers. We have one of the main, I mentioned in the very beginning of my talk, Daniel Borkman, who's one of the core eBPF maintainers in the kernel, is one of the founding engineers of Cilium as well. And a lot of the motivation for what he's done in building eBPF capabilities in the kernel is so that we can use it to build networking capabilities in Cilium. So we've got this huge knowledge of the kernel and eBPF. And what Tetragon's doing is taking that knowledge to build really powerful security tooling. The idea is that you can attach to events, filter them in kernel for performance reasons. You define the policy in YAML. So it's almost like you're writing your eBPF code in YAML and it's being compiled into eBPF. And using that policy to detect events that are interesting from a security point of view, and even potentially to enforce, prevent those out of policy events from taking place. The way that works is you've got this eBPF program checking that the event is, in or out of policy. And if it's out of policy, you have this option to kill the process responsible. And it sends a SIG-kill message directly from the kernel to kill that process. And that's happening synchronously. So other kind of security tools that essentially use eBPF to observe that an event happen, they typically going to pass that information to user space. Hey, something really bad's happened, like, your Slack message, something bad has happened. And you could go, oh, that's really bad. Even if you're an auto, you could be a bash script that says, I'm going to kill that process that's responsible for that out of policy thing. Mm-hmm. But it could have already happened. There's a window of opportunity that it could have already happened. If we kill the process from inside the kernel, it never got as far as opening that file. It can't have exfiltrated any data or anything. There's no window of opportunity. So personally, I'm really excited about the enforcement side. I think I am a little bit unusual in that. A lot of security folks are cautious about using enforcement and really just want to concentrate on observing out of policy events, because it's really hard to get your policy correct, and you don't want to be killing things that were completely legit. So rightfully, they are cautious about things that kill things. But if I look ahead to the future, I think that kind of runtime enforcement, we're going to start seeing, we have firewalls. We've had firewalls for years. Firewalls block network traffic. It's enforcement. And I think we will, over the course of time, we will start to get confidence in these kind of runtime policies that we can build at the right level to say not to say things like, at the system core level, but to say at the level that we understand as humans, I do not want any process editing the sudoers file. That feels like the kind of policy that I'm very confident about enforcing, and we should treat it like a firewall and make that impossible to happen.
Yeah. I was talking with somebody just a couple of days ago about why I think eBPF is kind of cool and why eBPF as a security concept is really interesting. And the way I described it is we hope we're running trusted software. We hope that we have like some kind of antivirus or whatever running and some kind of detection tools, but those are kind of reacting after the fact when we know this kind of thing happens. But with eBPF, we're looking at what's happening right now inside the kernel. So these kind of 0 days and whatever, I don't care what kind of process it is, which is trying to privilege escalate. I just want to stop it from happening. That doesn't mean that the other tools are useless. They're still very, very good, and I want to use them all. But just having that extra confidence that I'm looking at what's happening in the kernel now.
Yeah, I mean, that kind of layered approach to security, multiple different tools, multiple different approaches is absolutely the right way to go, defense in depth. Yeah, but I hope that we will get to a point where we can write policies in a way that humans know what consequences are going to have. If we think about things like seccomp or I'm struggling with the name, the file-based thing that they have in Red Hat. They're really, really hard to get the policy definitions correct. And we need things that are much easier for humans to look at the policy and go, that's something I have confidence in.
I think you're looking for SE Linux, my arch.
SE Linux, that's the thing. Yes. Yeah.
Fantastic.
Not enough coffee, obviously.
Yeah. Fantastic and a nightmare at the same time. All right, we've just got a couple minutes left, and I have one more question came into the chat. When compiling an eBPF program, does the size of the program matter? What I mean is when you want to write hundreds of lines of code and not just run once, but running in the background, will the compiler have a problem handling that?
Yeah, so the different stages that a program goes through, you're going to compile it from, let's say, C code to bytecode. Then you're going to load it into the kernel. It's going to go through the verification. And then it's going to be just in time compiled within the kernel to machine code instructions, native machine code instructions. Those steps only have to happen once. Excuse me. So it doesn't matter how many times after that's happened. You can trigger the same event, a million times. And if the program is unchanged, it doesn't have to go through any of those steps. It shouldn't matter. Now, I did mention before the complexity limit, which is 1 million instructions that the verifier looks at. In the past, in older versions of the kernel, that complexity limit was much lower. It was 4,000 instructions, I think. And that limited, you could hit that complexity limit pretty easily. But with 1 million instructions, you've got a lot of room to play with. And then there's also this idea of what's called tail calls that you can use to kind of chain BPF programs together. So it now means that there's effectively no, or at least, haven't found an example yet where people can't implement something in eBPF because of the complexity limit.
Right.
Hopefully we will be able to see more and more, particularly as people roll out newer versions of the kernel, they'll be able to take advantage of this.
But to learn more about tail calls, I can highly recommend Liz's book. Thanks a lot, Liz. It's been wonderful chatting with you, and thanks so much for the keynote as well. And I'm looking forward to seeing you in Amsterdam.
Yeah, absolutely, my pleasure. And again, thanks to everybody who's asked questions. I'm online on the platform as well, so if people want to carry on asking questions in the chat, I'll be online for a while. So great.
All right, thanks.
Thank you, Andy and Liz. And by the way, I just love your earrings.
Oh, thank you. Yeah, these are very eBPF specific. Thank you for noticing. All right, bye for now.
Bye.
Hi, we're from Eficode, and we're delighted to organize the DevOps Conference.
The interactive track at our conference has a unique opportunity for speakers and audience members to engage in dynamic conversations. It fostered a collaborative learning environment. Our tailored coaching services can also help you to overcome challenges in your software development life cycle. Let's have a chat.
Connect with us at eficode.com and let's push the boundaries of software development.